Section 12.2, vectors. So a couple learning goals. You should know basics of what vectors are, along with how to do appropriate calculations. I should also maybe say terminology. Let me add there, and terminology. And be able to perform various calculations and operations with vectors. So to start off this video, to start off a section, big question here is, what are vectors? And let me start by maybe saying what vectors aren't. So some quantities that we deal with in real-world applications don't really have a direction associated with them. If you want to say the quantity, 2 hours. 2 hours, there's not really a direction associated with the passage of time. If you have like a mass, a weight, I guess weight, it's pointing down at the center of the earth kind of thing. But other than that, just like a mass, if you have like a 1 kilogram sack of something, there's not really a direction associated with that. Well, in other things that other quantities we might have to deal with have directions associated with them. So I'm filming this video in the late afternoon. Earlier today, I drove for a bit. I drove for roughly 150 miles. It's perhaps not as satisfying to say I drove 150 miles as it is I drove 150 miles in the southwest direction. So, adding that direction on to the distance gives a lot more information about, what my travel was. If I had started off when I started off where I started from and went 150 miles in some other direction, I wouldn't have ended up at my house. So the distance and direction, both of those are important here. And so this kind of gets at the idea of what is a vector. Vector is going to be, something that has both a direction to it and a magnitude to it. And in practice, what we're going to do is that we are going to think about this kind of thing going on here. So a vector is going to be, we graphically represent them by an arrow pointing from one point to another point. We might call this point A our initial point, this point B here our terminal point, and this would be the vector AB. I'm putting a little arrow, with a half an arrowhead over top of that to represent this vector here. So let me just show this definition. The vector represented by a line segment AB has initial point, and I'm just realizing here I forgot a word here. It's very important that I include, it's not just a line segment, but a directed line segment. That there's a notion here of there's some kind of implied movement moving from point A to point B. It's not just a line segment, directed line segment. So the vector represented by directed line segment from A to B has initial point A and terminal point B. Initial point, terminal point. You start here, you end here. We care about length, magnitude. I'll use those terms, I'll introduce those kind of interchangeably later on, is to know by put little absolute value bars around AB. And we say two vectors are equal if they have the same length and direction. So a couple equal vectors here. Let me draw some axes here, x-axis, y-axis. So here is a vector from A to B. Here is another vector from C to D. Here is another vector from O, the origin, to E. here is another vector from, let's see, what letter am I on? F to G. So if I drew these, obviously I didn't draw them perfectly, but two vectors are equal, they have the same length and direction. I was trying to achieve that each one of these has the same length here, and they all are pointing in the same direction. So all of these vectors are going to have the same direction. Okay, so, and let me just kind of point out here, these are all parallel, same direction, and same length. So these are all equal to each other. Before I say anything else here, let me just talk a little bit about vector notation, because this is kind of important here. So first thing to realize is that the kinds of letters we tend to use here to represent vectors are going to be lowercase letters around U, V, and W, and that part of the alphabet. These are, so kind of big picture here. After U, V, W come X, Y, and Z. We usually reserve X, Y, and Z to be letters for, coordinate axes. Here, X, Y, and Z. In terms of, and then earlier letters S and T, those just don't really get used for vectors. So U, V, W are standard letters to put to be vectors here. Also, sometimes we'll have questions involving forces, and so we'll have a capital F for a force. Force is a vector quantity. So this idea from physics here, it comes up a lot, capital F. I also need to emphasize here putting the little arrows on top of our vectors. And so something that is traditional math is that you represent your vectors in a little bit of a special way here to indicate that, yes, they are vectors. So if you give me a second, I'm just going to get the textbook here and hold it up. Hopefully you can see it okay. So note here, in the textbook, they use boldface V and W. And so those are boldface V, boldface W, boldface U over there. You can tell that those are bolder. They are not just a regular print U, V, and W, they are boldface. So that is perfectly fine for textbooks to do that. But in practice, it's a little bit hard for people like you and me to show something as being bolded when we're writing on piece of paper. And so it's traditional for people like you and me to just put a little vector hat, that little arrow with a half arrowhead over the vector to make it clear that this is a vector quantity. And so throughout this class, we'll be having lots of things. Some things will be vectors, something will not be vectors. If you use this notation, I highly recommend it. I think that it will be very, very useful to you. Very, very useful to you to be able to distinguish between what are vectors and what are not vectors. Because distinguishing between vectors and not vectors is extremely important. Okay, so that's an introduction to what vectors are. Let's cut the video here, and we'll keep doing more vector stuff in the next video.